Alright, so in this video we're going to talk about dynamic memory allocation and using the new and delete keywords. So let's start with how we understand memory at this point. So most of what we're used to is writing our code, and a lot of what is happening in our code is the memory is getting allocated on the stack. And this is kind of how it works. So let's say we have a function called foo. And inside of main, we basically call the function foo. What happens is the function gets called and then the stack creates memory underneath where main was to store anything that's in the function. So in this case, we have just a vector. So that vector is going to get stored in this region of memory underneath main's memory on the stack. And so we're doing some stuff, we're filling the vector, we're printing it out, etc. But what happens is that immediately after we leave foo, everything that was allocated for foo on the stack gets destructed automatically. It just basically pops it off, right? And it disappears. And that's how memory is managed for the stack. And that's how the default memory is managed on like most of the stuff that you're doing. What would happen if we wanted to have access to vec, which is declared inside the function, outside of that function? Well, there's lots of things that you know about already to manage it within the stack, right? So you can declare the vector in main and then pass it in by reference. You could also just return it. You could return it, and so then you have access to it outside of it. Some of it is going to require copies, some of it isn't. But this is kind of like what you get to work with when you deal with memory on the stack. Its scope is within its function, right? That's kind of how it works. So another part of memory that we can use is called the heap. And you can think of it visually like I have here, where the heap is in one section and the stack is in the other, and they're kind of like growing in opposite directions. But what's different about the heap is that there's nothing that gets popped off the heap. It can stay there as long as you want. The stack has a limited size, and it's much, much smaller than the heap. And so a lot of times you need to allocate memory on the heap just because there's not enough room on the stack. In real problems, and the stack grows into the heap, so you can run out of space, which is what stack overflow means. And so the heap is a place that's larger, but it also is a place that the memory can stay as long as you want it to. So how do you make it go away? When does it go away if you allocate on the heap? There's no automatic time, but it's basically your job. If you are calling new, it's your job to manually let that memory go when you no longer need it. And so with object-oriented programming and with building classes, there's this natural sense of constructing and destructing, which is a really good way to manage it. But the point is that every time you call new, you have to call delete on that memory, otherwise it will never be let go. Until the program ends. So let's see. How does the new keyword work? Well, you're going to declare, and we're going to talk about the new and delete keyword with C arrays. You can also just do it on any pointer, but we'll just do it with arrays because it's what we're going to be using. So you need to create a variable that can point to some type. So it could be any pointer. It could be an int pointer, a string pointer, a pointer to a vector, object, whatever it is. And then with C arrays, which is what we're going to be using a lot, you can do this in 2 steps or 1 line. So you have any type here, so integers, strings, whatever, and this is going to be a pointer that points to whatever type you've typed it as. And then this is what actually allocates the space. So let's say that these are integers, so we'll have an int here and an int here, and let's say size is 4. The T star is just going to be a pointer and that pointer is ready to point to whatever it needs to. And then when you do this step here, it's actually going to allocate the memory of whatever it's pointing to. So if it's an integer array, it's going to, let's say, just create 4. And so the right-hand side makes space on the heap, and then the left-hand side is going to point to that space. You can also do it in the same line as well. And that's how the new keyword works. That right-hand side is the key. If you put new plus the allocation, then it puts it on the heap. This allocation is a fixed size. There's no bounds checking. So, it literally lets you do anything. So you have to really know what you're doing. I'm going to give you a tool at the end of this video that you can help understand if you're doing it correctly, but you have to understand your memory when you start calling new. There's nothing that's built in to check it for you. So when you allocate memory on the heap, if you go off of that memory, because it's just a pointer, right? So you can move along the pointer wherever you want. It's not going to stop you, so you have to control that. So you could just get garbage, you could crash your program. It allows people access to data that you might not want them to. If you're interested more in that, look up buffer overflow. And so you really have to manage this at a deep level. There's no getting around it. So when you declare local variables or parameters without the new keyword, C++ automatically handles that memory allocation and deallocation for you. So when you just do int x equals 1, you don't have to get rid of that integer. It does it for you, right? But when you use new, it's your job. You're allocating the memory, so you also have to deallocate it. And that's why people like C++ and what makes it so powerful is it gives you that power, basically, to do that. If you don't do that, you can get a memory leak, and that can cause the program to crash. It's really, really important that you write code that doesn't leak memory. Once you have that memory allocated, then the counter call for every new is delete. So anytime you have created memory, you're going to delete it. And the syntax that I'm giving you here with the delete and the square bracket operator is going to destroy the array that the pointer points to. So here you can see the pointer points to this array. When you call delete, it destructs the data that it points to. It doesn't destruct the pointer itself, so the pointer is still there if you would like to point it to something else. That the memory that stores the pointer is still available to your program. And so you don't need to go through and walk through the array, which is one of the nicest things that C++ has done for us, is at least when you call delete square bracket, it deletes the entire array. You don't need to go through and walk through each of those elements and destruct and call delete for each one. You can just call delete square bracket. There's also a call called delete that will just delete, the one item that it points to, not the whole array. So once you've deleted it, that pointer still exists. It's now a dangling pointer, just like when we declared it a pointer before and didn't set it to anything. So it can be reused for something, but if you never reuse it, it's just going to be this pointer that is declared that points to nothing. And so if you start to dereference it or try to access what it points to, all sorts of crazy things can happen. So as a summary, you can create fixed size arrays at runtime using new. Be careful though, because C++ arrays don't know their lengths and there's no bounds checking. So with this power comes a lot of responsibility, and you're going to notice it right away. This is the time in the class where you're going to see all sorts of errors that you've never seen before. They all start with SIG, and it's all in your control now. So you're responsible not only for making sure that you're accessing only the memory that you have given yourself permission to access, but you're also responsible for freeing any memory that you have explicitly allocated. And then once you have deleted the memory, you still have access to that pointer probably the scope of your object has gone out of scope and it doesn't really matter. But if you are working with some copy constructors or some equals constructors, which we'll talk about in the next video, you'll see that you can reuse that pointer. So how can we check to see if we're doing this right? Well, there's a tool called Valgrind, and right now you don't really necessarily need to use it. We will test all your code with Valgrind to make sure you have freed all of your memory and that you're not accessing memory outside of what you've allocated. But for the first project, there's not a whole lot that you can abuse, but I guess we'll see. And the way that we'll check that is we'll use this tool called Valgrind, which runs in a Linux operating system. Your makefile allows you to run Valgrind, so you can run it yourself and see how it works. Basically what you're looking for is a clean Valgrind report. So this might not look clean to you, but this is saying that I have allocated 2 things and I've freed both of those. So that is good. No leaks were found and there are 0 errors. Now, if you have not done this properly, like for example, if you run this without writing your destructor, which we'll talk about in a second, you'll see that this won't be the report that you get. You'll see that you have errors and you have leaks, and you don't want either of those 2 things if you've managed your memory correctly. Okay, so that is it for this video on dynamic memory allocation.